Welcome to VerseLab Podcast. Today we are going to discuss something entirely different. We are taking a dive into data management, and DAMA is our source. And to kick this off, I want you to imagine something. Imagine a global, multi-billion-dollar bank that literally doesn't know how much money it has on hand on any given Tuesday.
Right, which sounds completely insane.
It sounds absurd, not because someone robbed them, but because, like, 3 different legacy computer systems inside this bank define the word profit in 3 completely different ways.
Exactly.
So they try to merge the spreadsheets, and the total just fluctuates by hundreds of millions of dollars, depending on which server you happen to ask.
Yeah, and you'd think that's impossible today, but right now, incredibly successful companies are quietly hemorrhaging money, they're alienating customers, and risking, total regulatory ruin because of this invisible, chaotic data infrastructure.
It's totally wild.
It really is the ultimate hidden crisis of the modern economy. I mean, we are so comfortable dealing with physical assets, right? You can walk into a warehouse, count the pallets of inventory, or point to a fleet of delivery trucks.
Sure, you can physically see them.
Exactly. But the second you step into the information economy, the organization's most valuable asset becomes entirely invisible. We're talking about petabytes of silent information flowing through server farms.
Just making automated decisions in milliseconds.
Yeah, driving massive revenue streams, but also carrying catastrophic risk. And most people, even senior executives sitting up in the C-suite, have absolutely no idea how that hidden universe is structured, or how it's kept from just, collapsing under its own weight.
Which perfectly brings us to our mission for this deep dive, because if we are dealing with this massive, invisible, chaotic universe, there has to be a map.
There is, thankfully.
Right? And our source material today is essentially the ultimate playbook for mapping that territory. It's the DAMA DMBOK2, the Data Management Body of Knowledge, 2nd edition.
A very heavy book, by the way.
Oh, incredibly dense. DAMA International spent decades compiling this thing. It's basically a synthesis of best practices from thousands of data management professionals across the globe. So our goal today is to completely dissect this massive framework.
Yes, break it all down.
For you listening, we want to translate these really dense architectural concepts into an aha journey. We're going to change how you view the digital scaffolding that runs everything around you.
Because every time you swipe a credit card or a package magically arrives at your door on time, there is a sprawling data management apparatus making that possible. And we need to understand the mechanics of how it actually works.
So to do that, we're going to rely on the primary visual framework from the text, right? The DAMA Wheel.
Yeah, the DAMA Wheel. It's a conceptual model that organizes data management into 10 core knowledge areas, and they all revolve around a central hub.
Like spokes on a wheel.
Exactly. It's brilliant because it forces you to see how completely interdependent these disciplines are. I mean, you cannot have data security without data architecture. You can't have business intelligence without data quality. We're going to explore all those connections deeply.
But before we start, drawing the map and looking at the spokes of this wheel, we have to establish the territory. Chapter 1 of the DMBOK talks about this fundamental paradigm shift that we really need to internalize.
The shift in how we even define data.
Yeah. Because for a really long time, and honestly, in a lot of legacy companies even today, data is just viewed as the exhaust pipe of IT.
Right, just a byproduct.
Exactly. You build an application to automate your payroll, and the data is just the digital paper trail that the software spits out.
That historical view basically treats data as an afterthought. But the DMBOK forces a complete redefinition here. It defines data management as the development, execution, and supervision of plans and practices that enhance the value of data assets throughout their life cycles.
Notice the vocabulary there. Enhance the value of data assets.
Yeah, the text repeatedly describes data as the currency, the lifeblood, or the new oil of the economy. It is no longer the exhaust, it's the fuel.
Let's look at the mechanical difference between those two states, though. Because the text makes a foundational distinction between data and information.
Which people usually just use interchangeably, right? At dinner parties, they mean the same thing.
Right, but the DMBOK uses a very specific hierarchy to separate them, usually visualized as the DIKW pyramid. At the very bottom, you have the raw material, data.
Just raw facts.
Yeah, data is just a fact. It's a string of characters. If I just hand you the number 10,000, that is raw data. On its own, it's entirely meaningless.
Completely. Without a frame of reference, 10,000 could be $10,000 in profit, 10,000 miles on a used car, or, 10,000 employees being laid off.
Exactly.
So the whole process of data management is moving that raw fact up to the next level of the pyramid, which is information. Information is data placed into
It's
context.
been organized.
Yes, structured to actually convey meaning. So if the system specifies that 10,000 represents the number of units sold of a specific microchip in the European market during the third quarter, now you have information.
And as you move further up that pyramid, information becomes knowledge. Like seeing the historical trends of those microchip sales over 5 years.
Right.
And knowledge eventually becomes wisdom or insight-like, making the strategic decision to open a new manufacturing plant in Germany based on those trends.
But here's the kicker. None of that higher-level boardroom decision-making is functionally possible if the base layer of the pyramid, the raw data, is fundamentally flawed.
Right, if the 10,000 number was just a typo.
Exactly. That is the crisis facing modern executives. They want the wisdom, they want the predictive analytics, but they are trying to build it on a base of unmanaged, unstructured, messy, raw data.
Okay, I want to push back on this idea of data as an organizational asset, though.
Okay, go for it.
The DMBOK insists that data has unique properties and its value should be expressed in economic terms. But let's look at corporate reality. If data is officially recognized as an enterprise asset on par with cash, why doesn't it show up on a company's balance sheet?
That's the golden question.
Right. If it's the new oil, why isn't it accounted for under generally accepted accounting principles GAAP alongside real estate and factory equipment?
Because traditional GAAP accounting falls completely apart when applied to something that literally defies the laws of physics.
How so?
Well, our entire financial system was designed for the industrial age. Physical assets deplete when you use them. If you burn a barrel of oil, it's gone forever.
Right.
If you hand someone a physical $20 bill, you no longer possess that $20 bill. Physical assets also experience standard depreciation.
But data doesn't deplete. I can query that exact same data set about third quarter microchip sales 1 million times a day across 100 different global departments, and the data never wears out.
Exactly. It's non-depletable. It's incredibly easy to copy and virtually frictionless to transport. But here is the most difficult accounting problem. Its value is entirely contextual.
What do you mean by contextual?
So a physical delivery truck has a relatively objective market value, right? You can look up what it's worth. But a massive data set containing consumer purchasing behaviors, that might be worth tens of millions of dollars to the marketing department trying to target a new ad campaign.
Right.
But that exact same data set is worth absolutely $0 to the facilities management team who are just trying to replace light bulbs.
Oh, wow. Yeah.
So because of these fluid, non-physical properties, the accounting world hasn't yet formulated a standardized, legally binding way to put a hard dollar figure on a balance sheet.
But that creates a massive psychological blind spot for leadership, doesn't it? If the CEO doesn't see a $50 million line item for data assets on the quarterly balance sheet, they naturally won't want to approve a $5 million budget to maintain and govern it.
It remains invisible to them, which is exactly why the DMBOK establishes the principle that data management requirements are business requirements. It cannot be sidelined as just an IT problem.
Right, because IT just builds the pipes.
Exactly. When an organization treats data strictly as an IT problem, they just throw developers at it and say, hey, build us a database. But IT doesn't know the business context of the data.
They don't know what the data actually means.
No, IT doesn't know what a customer means to the sales team versus the legal team. Managing this asset requires cross-functional skills. You absolutely need the technical engineers to build the infrastructure, but you desperately need the business stakeholders to define the data's meaning, its usage rules, and its quality thresholds.
So if data is this massive, enterprise-wide asset that behaves unlike any physical asset in human history, and it requires this delicate collaboration between the server room and the boardroom, you can't just wing it.
No, absolutely not.
If every department builds their own databases with their own definitions, you get the global bank scenario I mentioned at the start. You need a map to navigate the chaos. And this takes us to the visual frameworks DAMA uses to structure this discipline.
Yeah, the DMBOK relies on several frameworks because data management involves a highly complex set of interdependent functions. To start from the absolute top down, they reference tools like the Strategic Alignment Model and the Amsterdam Information Model.
Which are basically conceptual bridges, right?
Yes. They dictate that business strategy must dictate IT strategy. You cannot design a data architecture until you deeply understand the business processes that architecture is meant to support.
But the real star of the show, the defining diagram of the DMBOK, is the DAMA Wheel. I'm looking at this structure right now, and the most intuitive analogy really is a bicycle wheel.
It's a great analogy.
You have all these distinct spokes, 10 different knowledge areas connecting to the outer rim, but every single one of them converges on a central hub.
And the hub of the DAMA wheel is data governance. Around it are the 10 spokes: data architecture, data modeling and design, data storage and operations, data security, data integration and interoperability, document and content management, reference and master data, data warehousing and business intelligence, metadata, and data quality.
That's a lot of spokes. But the bicycle wheel analogy is perfect because of the mechanical reality of how a wheel works. The spokes are under tension.
Yes.
If you remove the central hub, if you strip away governance, all those independent spokes immediately collapse inward. The entire structure shatters.
Exactly. Architecture, security, and quality cannot exist in a vacuum without a central governing body holding them in alignment.
The wheel shows the complete scope of the discipline, but the text also offers alternative frameworks to show the evolution of these practices, right? Like Aiken's pyramid.
Yeah, developed by Peter Aiken. The whale shows you what you need to do, but the pyramid shows you the strict order of operations.
Because companies always want to jump straight to the sexy cutting-edge technologies.
Always. Everyone wants to talk about big data, machine learning, and predictive analytics.
Right, but Aiken's pyramid places those advanced practices at the absolute peak.
Because trying to implement machine learning without foundational data management is a recipe for expensive failure. Phase 1 of Aiken's pyramid is establishing core practices: data architecture, modeling, and storage.
You literally have to build a database before you can use it.
Exactly. Then phase 2 is integration and data quality, making sure the data moving between systems is actually accurate. Phase 3 is master data and warehousing, creating a single version of the truth. Only after you have mastered those 3 foundational phases can you move to phase 4, which is the advanced analytics.
Imagine a company spending $20 million on an AI initiative to predict customer churn. If they haven't done phase 2 data quality, the AI is going to train itself on duplicate records, outdated addresses, and just contradictory purchasing histories.
It's the classic garbage in, garbage out paradigm.
But scaled up to enterprise-destroying levels. You cannot build a penthouse suite on top of a digital swamp.
You really can't. The DMBOK also highlights a framework evolved by Sue Granz, which takes the DAMA wheel and stretches it out linearly into a life cycle. It reminds us that data is not static.
It has a lifespan.
Right. It is born, it's designed, it's maintained, it's utilized, and eventually it has to be archived or destroyed. Granz breaks it into plan and design for architecture and modeling, enable and maintain for storage and integration, and use and enhance for business intelligence.
And wrapping around that entire chronological life cycle is, again, data governance.
Always governance.
So since governance is the literal center of the wheel, the tension holding the spokes together, and the oversight wrapping the entire life cycle, we have to start our deep dive right at that hub. What does it mechanically mean to govern data? Because for the average employee, that word sounds incredibly bureaucratic. It sounds like red tape.
It is often perceived that way, definitely. But the DMBOK defines data governance very specifically. It is the exercise of authority, control, and shared decision-making over the management of data assets. It's the formulation of strategy, policy-making, and oversight.
The text highlights a quote from John Ladley that creates a really sharp distinction. It says, data governance is doing the right things, while data management is doing things right. That separation of duties is critical. Data management represents the technical execution. It's the developers, the database administrators, and the engineers writing the code and tuning the servers. They are doing things right.
Okay.
Data governance is the legislative body. It's a council of business leaders and data stewards deciding what data actually needs to be captured, who is legally allowed to see it, and what quality metrics it must hit to be considered valid. Governance sets the rules of engagement.
And the text outlines different operating models for how an organization can set up this legislative body. You don't just force a single hierarchical structure on every company. It outlines centralized, replicated, and federated models.
Right. It comes down to the distribution of decision-making power. A centralized model is exactly what it sounds like. One central data governance council makes all the rules for the entire global enterprise, which ensures total consistency. But I imagine it can be incredibly slow and rigid.
Very slow. Then a replicated model means the same governance structure is adopted by each individual business unit, operating somewhat independently.
And a federated model. How do they resolve conflicts when, like, Local branches disagree with headquarters.
The federated model is actually the most common for massive, complex enterprises. You have a central enterprise governance body that sets high-level, non-negotiable policies. For example, sweeping cybersecurity standards.
Right.
But each distinct business unit has its own local governance council. They make decisions specific to their local market needs as long as they don't violate the enterprise umbrella policies.
So what happens if there's a clash?
If a conflict arises, say, the European branch needs to implement strict data masking to comply with local privacy laws, but the global marketing team in the US is demanding unmasked data for a campaign, the federated structure escalates that to the Central Council.
Oh.
And the Central Council doesn't just automatically side with IT. It weighs the legal risk against the business value and issues a binding ruling.
But governance isn't just about resolving internal business disputes or setting data definitions, right? Chapter 2 of the DMBOK introduces a layer that is intensely relevant today: the ethical dimension of data.
Yes, ethics is a huge part of governance now.
Because we are collecting behavioral telemetry on human beings at a scale that is historically unprecedented, the framework actually adapts principles from bioethics, specifically the Belmont principles used in medical research trials, and applies them to corporate databases.
It's a profound realization that a database is not just rows and columns, it is a proxy for human lives. The core bioethical principle they adapt is respect for persons. In a medical trial, that means you cannot experiment on a patient without their informed consent, and you must respect their bodily autonomy.
When you translate that to data architecture, how does respect for persons physically manifest? Because we aren't testing experimental drugs, we're analyzing click streams.
It manifests through transparency, consent mechanisms, and privacy by design. If an organization is quietly scraping a user's geolocation data, selling it to third-party data brokers without the user's explicit knowledge, and using that data to manipulate their purchasing decisions or insurance rates, they are fundamentally violating the user's autonomy. They are treating the human being merely as a means to an end, a raw material to be exploited, rather than a person worthy of respect.
I really appreciate that the DMBOK tackles this strictly from a corporate risk and policy perspective, though. This isn't just a philosophical debate, it's operational risk management.
Exactly. Unethical data practices lead to structurally biased algorithms.
Right. If your historical lending data is inherently biased against certain demographics, and you feed that raw data into a machine learning model to automate loan approvals, you've just hard-coded discrimination into your enterprise architecture.
Which is a disaster. It destroys consumer trust, and when the inevitable data breach happens because sensitive data was recklessly hoarded, the reputational damage is existential.
So establishing an ethical data culture is a primary function of the governance hub.
Yes. Governance provides the oversight to step in and say, we possess the technical capability to scrape this data and correlate these variables, but doing so violates our ethical policy and exposes us to unacceptable legal risk.
But this brings up a harsh cultural reality. When you use words like authority, control, oversight, and ethical policy, governance sounds exactly like the data police.
It does.
Let's say I'm a mid-level business analyst. I just want to pull some historical sales numbers to run a quick quarterly report. I do not want to fill out forms in triplicate and wait 4 weeks for a data governance council to debate the bioethics of my SQL query.
Nobody wants that.
How does a company implement this massive hub without creating a paralyzing bottleneck where employees are literally incentivized to just avoid the official systems?
That is the tightrope walk of the entire discipline. If governance is perceived strictly as a policing function, it fails entirely. The business will simply route around it. Analysts will export the data into hidden spreadsheets, run their reports locally, and create what we call shadow IT.
So how do you reframe it to avoid shadow IT?
The DMBOK stresses that effective governance is an enabling function, not a restricting one. Think about the infrastructure of a major city. Governance is not a police officer pulling you over every 10 feet to check your license.
Okay.
Governance is the traffic light system, the painted lanes, and the highway signage. By instituting standard rules of the road that everyone understands, millions of cars can travel at high speeds without colliding.
That makes total sense.
Good data governance provides the traffic lights and the clear definitions so that you, the business analyst, can pull your quarterly report faster with total confidence that the numbers you are looking at are accurate and legally cleared for your use.
You govern the data so the business can actually move faster safely. Okay, so we have established the rules of the road with the governance hub. But rules do not build houses. Once you have the zoning laws and the strategy, you need a blueprint. You have to translate the abstract governance policies into physical, working technology.
Right, you move into the build phase.
Which brings us to three deeply interconnected spokes on the DAMA wheel: data architecture, data modeling and design, and data storage and operations.
These three areas represent the physical realization of the business strategy. Let's start from the macro level. Data architecture. A data architect surveys the strategic goals of the entire enterprise and designs the master blueprint.
Right.
They dictate how data should flow between the HR systems, the supply chain systems, and the customer-facing applications.
Sticking with the city infrastructure metaphor, data architecture is the master city planner. They look at the geography and say, the residential district goes here, the industrial manufacturing goes there, and we need a 6-lane highway connecting them to the port. They aren't worrying about the color of the paint on the houses. They're designing the macro-level flow of the city.
Exactly. But once the city plan is approved, you have to actually design the individual buildings. That is data modeling and design. While the architect looks at the macro enterprise flow, the data modeler zooms in to design the specific schematic of a database.
Okay.
Data modeling is the highly structured process of discovering, analyzing, and scoping data requirements, and then representing those requirements in a precise, standardized visual form called a data model.
So it's the floor plan of the house, showing where the load-bearing walls are, where the plumbing runs, and how the kitchen connects to the dining room.
Yes. And mechanically, a data model defines the entities, which are the nouns of the business, like customer, product, or order, and the strict rules governing the relationships between them.
Give me an example of those rules.
For instance, in a relational database, a modeler must define cardinality. They have to explicitly document whether one customer can place multiple orders, which is a one-to-many relationship, or if a single order can somehow belong to multiple customers, a many-to-many relationship.
Right.
If the modeler gets that relationship rule wrong, the entire database will physically fail to process reality.
Because you wouldn't hand a pile of 2x4s to a carpenter and just say, build a house. You need the architectural floor plan so the roof doesn't cave in.
Exactly.
And that takes us to the third spoke of this group: data storage and operations. If the model is the floor plan, storage and operations represent the concrete foundation, the heavy machinery, and the property managers who actually keep the lights on.
This is the domain of the database administrators, the DBAs. Once the data model is finalized, the DBAs execute it. They build the physical tables in the server environment, but their mandate extends far beyond construction. Storage and operations is about managing the intense day-to-day life cycle of that physical infrastructure.
What does that actually look like mechanically?
It looks like managing performance tuning. If a database grows to contain 10 billion rows and a user runs a query, it shouldn't take 6 hours to return an answer.
Right, nobody has time for that.
So the DBA builds indexes and optimizes the storage so the answer returns in milliseconds. It involves ensuring high availability, making sure the system doesn't crash when thousands of concurrent users log in during a Black Friday sale.
Very important.
And critically, it involves business continuity, executing rigorous backup schedules and disaster recovery plans so that if a massive server farm in Virginia loses power, the system instantly fails over to a backup site in Ohio without losing a single transaction.
They really are the unsung engineers keeping the digital heartbeat of the company alive. But the text highlights a fascinating, very real cultural friction point that occurs in almost every IT department during this build phase. There is essentially an ongoing Cold War between software developers and database administrators.
It is a massive clash of incentives and fundamental frameworks. Software developers, especially those operating under modern agile methodologies, are inherently incentivized by speed, flexibility, and feature delivery.
They want to move fast.
Right. Their goal is to write code, push updates to the user interface, and iterate as rapidly as possible.
Let's simulate this clash. Let's say a developer is building a new mobile app for the sales team, and they realize halfway through a 2-week sprint that they need to track the customer's age and their favorite color.
Okay.
Under an agile mindset, the developer just wants to run a quick script to add 2 new columns to the live database right now so they can finish their feature by Friday.
And the DBA will aggressively block that request.
Instantly.
Because the DBA is incentivized by stability, performance, and long-term data integrity. The DBA looks at that request and says, wait, you want to add a customer age column? Age changes every year. We don't store age, we store date of birth and calculate age dynamically.
Right, that's just basic logic.
And then they'll say, furthermore, If you add a favorite color column to the core customer table, it breaks the enterprise data model. Have you documented this change? Will adding these columns corrupt the downstream financial reporting systems? Will it degrade the query performance for the 1,000 other applications relying on this database?
So the developer sees the DBA as an obsolete, bureaucratic dinosaur standing in the way of innovation and speed.
And the DBA sees the developer as a reckless teenager who is going to accidentally corrupt the entire enterprise architecture for the sake of a minor app feature.
Overcoming that cultural hostility requires the governance hub we talked about. It requires clear policies so the developers understand the vital necessity of data integrity, and the DBAs adopt processes to support rapid development without compromising the foundational vault.
Because if the vault is compromised, everything built on top of it collapses.
So we have built our architectural vault, we've governed it, modeled it, and optimized it. But here's the paradox of data. If you keep it perfectly locked down in a vault, it's completely useless. The value of data comes from its liquidity. It has to move. It has to be integrated into new systems, analyzed by different departments, and shared across the globe.
Yeah.
But the exact second data begins to move, it becomes highly vulnerable. How does the DAMA framework reconcile the necessity of utility with the reality of vulnerability?
It addresses it through the next three heavily intertwined spokes of the wheel: data security, data integration and interoperability, and data quality. Let's tackle security first, because moving data is exposed data.
Right.
Data security involves the planning, development, and execution of policies and procedures to provide proper authentication, authorization, access, and auditing. The ultimate goal is to protect information assets from unauthorized access, malicious usage, or theft, while simultaneously allowing legitimate business users to do their jobs frictionlessly.
The text mentions utilizing frameworks like the NIST Risk Management Standard for Cybersecurity. But it points out something incredibly foundational that most companies get wrong. The very first step in protecting data is simply knowing where it is. You have to use your enterprise architecture models to map out exactly where your sensitive information resides. You cannot put a biometric lock on a door if you don't even know the door exists.
Consider the reality of a massive legacy corporation. They might have a forgotten server sitting in a closet in a regional branch office running an outdated marketing application from 2012 that contains 3 million unencrypted social security numbers.
A ticking time bomb.
Exactly. If the security team doesn't know that database exists, they cannot secure it. Discovery is step one. Once discovered, security implements mechanical controls like encryption at rest, data masking in transit, and highly granular identity management.
The text brings up an acronym for this granular control. The CRUD matrix. CRUD. I'm looking at this and I imagine it functions very much like keycard access in a high-security government building.
That is an excellent way to visualize it. CRUD stands for Create, Read, Update, and Delete. It is a fundamental security mapping tool. For every single data element in the enterprise, you must define exactly which user roles have which specific permissions.
So the entry-level customer service representative's keycard might grant them read access to view a customer's billing history so they can answer a phone question.
Right.
But they absolutely do not possess delete access to wipe out that customer's debt. Only a senior financial manager's keycard has the update or delete permissions.
And critically, every single time one of those actions is taken, the security architecture generates an immutable audit log. We know exactly who updated the record, at what millisecond, from which IP address.
So we have secured the data, but how does it physically move between these isolated systems? That is the domain of data integration and interoperability. We've talked about how legacy companies operate in silos. The HR database doesn't talk to the accounting database.
Yeah, they're on totally different planets.
So integration is the discipline of breaking down those silos to move and consolidate data. The text highlights a classic mechanical process for this, ETL.
ETL stands for Extract, Transform, and Load. It is the workhorse of data integration. You extract data from a source system, say, pulling a massive batch of daily sales receipts from the point of sale servers.
Okay, that's the...
Then you transform that data in transit. Transformation is where the heavy lifting happens. You might be converting European date formats to American date formats. You might be stripping out special characters or translating a legacy product code into a modern inventory code. And finally, you load that newly standardized data into the target destination, like a massive data warehouse for analysis. Today, this discipline also encompasses real-time interoperability through enterprise service buses and data virtualization, allowing applications to communicate instantly internally via APIs.
But the act of moving and transforming all this data from disparate silos brings us face to face with the most agonizing, expensive reality in all of corporate IT: data quality.
Oh, yes.
The DMBOK defines data quality simply as ensuring data is fit for purpose. Let me play devil's advocate here for a second.
Sure.
We live in the era of artificial intelligence. We possess staggering computing power. We have machine learning models that can write poetry and write software code. Isn't bad data quality largely a solved problem?
You'd think so, but no.
But why? Can't I just point an AI at a massive, messy spreadsheet, let the computer figure out that Saint and Street are the same thing, automatically fix all the typos, and output a perfectly clean data set?
Oh.
Why do we still need human-led, manual data quality teams?
It is the most common and most dangerous misconception in modern business. Technology alone cannot solve data quality because AI lacks business context.
What do you mean?
Well, algorithms are fantastic at identifying syntactical anomalies. An AI can easily profile a column of phone numbers and flag the ones missing a digit. But syntax is not the core problem. The true monster hiding in enterprise systems, as the text highlights, is data disparity.
Explain the mechanics of data disparity. How is it different from just a data error?
A data error is a typo. Data disparity is a fundamental semantic conflict in how data is structured and defined across different systems. Let's return to the massive global bank scenario we discussed earlier.
Okay.
Let's say Bank A acquires Bank B. They want to merge their systems and report their combined total active customers to Wall Street. The AI can clean up the names and standardize the phone numbers perfectly.
But what happens when Bank A defines an active customer as anyone who has executed a financial transaction within the last 12 months, whereas Bank B defines an active customer as anyone who has an open account, even if it has been sitting dormant with a zero balance for 5 years?
That is data disparity. The AI has absolutely no idea how to resolve that philosophical conflict. It cannot automatically clean that data because neither definition is technically wrong. They are just semantically incompatible.
Oh, yeah.
If you just dump both databases together and run a sum, your resulting total active customers metric is a complete fiction. It is a hallucination. Your financial projections will be entirely wrong, and you will be lying to your shareholders.
An algorithm cannot negotiate a corporate treaty.
No, it can't.
It requires human beings, data stewards, representing both banks, to sit in a room, hammer out a newly shared definition of what an active customer means for the merged entity, and then explicitly instruct the ETL integration systems on how to logically map the old data to the new reality.
Exactly. Data quality depends on everyone who interacts with the data across its entire lifecycle. It requires establishing rigid quality dimensions like completeness, uniqueness, and validity, measuring the data against those dimensions, and remediating the root causes of bad data at the point of entry, not just trying to scrub it after the fact.
This challenge of rampant data disparity leads directly into the next phase of our map. When you have dozens of different departments operating globally, all referring to customers, products, and employees differently, how do you finally enforce a single version of the truth?
You need a master translator.
And that introduces the critical spokes of reference and master data alongside document and content management. Let's start with the pursuit of the golden record.
Master Data Management, or MDM, is arguably the most strategically vital area of data management for a complex enterprise. MDM is the ongoing reconciliation and maintenance of core, critical, shared data across the organization.
Right.
Every business relies on fundamental entities: the customers they sell to, the products they make, the employees they hire. Master Data Management ensures that there is a consistent, accurate, timely, and universally accessible version of truth about these entities.
To understand the sheer gravity of this, let's step outside of banking and look at a life-and-death enterprise scenario.
Okay.
Imagine a massive regional healthcare network that has acquired several smaller hospitals. Hospital System A admits a patient named William Smith, who is subsequently prescribed a heavy dose of blood thinners. Across town, Hospital System B has a patient named Bill Smith scheduled for major cardiovascular surgery the next morning.
If that healthcare network does not have robust master data management performing what we call entity resolution, which is the complex algorithmic and probabilistic matching to determine that the William Smith in System A is the exact same biological human being as the Bill Smith in System B, the surgical team will not know he is on blood thinners.
And Bill bleeds out on the operating table.
Yes.
Master data management is not just administrative cleanup. It is operational life and death. It creates the golden record that every single application in the enterprise must reference.
Closely related to this is reference data management. If master data is the nouns of the business, the people and the products reference data provides the adjectives and the categories. It is the data used to classify other data.
Give me an example.
Think of country codes, currency codes, or industry standard medical diagnostic codes. If your European supply chain system uses GBR to denote the United Kingdom, and your American accounting system uses UK, your global logistical reporting will fail to aggregate. Reference data management ensures every system uses the exact same standardized drop-down lists.
So we establish a common vocabulary for our highly structured relational databases. But the DMBOK does not limit itself to neat rows and columns. It also tackles the chaotic, unstructured Wild West of organizational information, document and content management.
Which is a huge part of the problem.
We're talking about the millions of emails, PDF contracts, Word documents, slide decks, and training videos scattered across the company network. Let's talk about the relatable nightmare of the final v2.docs file.
We all know the scenario. A team is collaborating on a critical quarterly report. Someone saves it as final report CV2.docs.
Right.
The next day, someone else makes changes and saves it as final report v2 of final.docs. By Friday, you have final report v2 actual final with edits used as own.docs sitting on 3 different laptops and attached to a dozen email threads.
When a small team does that, it's an annoyance. When a Fortune 500 corporation does that with multi-million-dollar vendor contracts, it represents massive financial and legal liability.
Exactly. Managing unstructured data requires the exact same rigorous governance, security access controls, and quality standards as managing a SQL database. A PDF contract is a critical corporate asset.
So how do you manage it?
Document and content management involves establishing enterprise taxonomies, meaning a strict, agreed-upon hierarchy of folders and metadata tags so a document can actually be found. But more importantly, it covers the complete lifecycle, including archiving and legal retention policies.
The text mentions the critical mechanics of e-discovery. E-discovery is the legal process where a judge orders a corporation to produce every single internal communication and document related to a specific topic over a 5-year period for a lawsuit.
Right, and if your enterprise file storage is just a chaotic swamp of millions of Final V2 documents scattered across thousands of unmanaged laptops, you cannot comply with that subpoena.
Or worse, if your system automatically deletes an email that was supposed to be preserved under a legal hold because you lacked a content lifecycle management system, it is considered spoliation of evidence.
Which is devastating.
The judicial system can impose staggering financial penalties or instruct the jury to assume the deleted emails proved your guilt. The DMBOK advocates for litigation response playbooks and data maps to manage this exact operational risk.
Yeah, you have to be prepared.
So we have governed our data landscape. We have architected the master plan, modeled the databases, and stored the information securely. We have integrated the silos, cleansed the semantic disparity, established a single master version of the truth, and organized our unstructured documents.
We've done the work.
The vault is secure, pristine, and humming. Now, how do we actually extract value from it? How do the business users find what they need to make strategic decisions?
This is the payoff.
Right. This brings us to the analytical crown jewels of the DAMA Wheel, data warehousing and business intelligence, powered by the absolute secret hero of the entire DMBOK framework, metadata.
Let's start with the ultimate destination for the business user. Business intelligence, or BI, which relies entirely on data warehousing. We need to distinguish between an operational database and an analytical database.
Okay, what's the difference?
The operational databases we built earlier are designed for high-speed, localized transactions. When you scan a barcode at a cash register, an operational database processes that single transaction in milliseconds and says, approved.
But if the CEO wants to know the 5-year profitability trend of that specific product line across the entire Asian market, you cannot ask the cash register database.
No, it would crash the system trying to compile millions of historical rows.
Precisely. That is why we use ETL to extract the data out of the operational systems and load it into a data warehouse. A data warehouse is a massive, consolidated repository specifically structured and historically optimized for complex querying, reporting, and analysis.
Right. The warehouse is the engine that powers business intelligence. BI is the dashboarding, the data visualizations, and the predictive modeling that knowledge workers use to discover trends, identify market anomalies, and steer the corporate ship.
But here's the catch. You can build the most powerful, expensive data warehouse in the world, filled with perfectly clean master data. But if the business users do not know what the data actually represents, they won't trust it, and they won't use it.
It becomes a digital ghost town.
Exactly. This is where we introduce the most crucial element in the entire DMBOK. The framework references it constantly. It is the connective tissue of reality, metadata.
Metadata is, simply put, data about data. It is the context that makes the raw information comprehensible. Without metadata, everything we have discussed so far completely unravels.
The text provides a brilliant, instantly understandable analogy for this. Imagine an organization without metadata as a massive, sprawling library containing millions of books. But there are no labels on the spines, no signs on the aisles, and there is no central card catalog.
The knowledge, the information, is physically located somewhere inside that building, but is functionally invisible and entirely inaccessible to the patron walking through the door. Metadata is the card catalog. It describes the data, documents its lineage, and maps the conceptual connections between different systems.
The DMBOK breaks metadata down into two primary interconnected categories, right? Technical metadata and business metadata.
Yes. Technical metadata is the language of the systems. It is what the database administrators rely on. It documents the physical table names, the server locations, and the structural constraints, like knowing a specific column is strictly limited to 50 alphanumeric characters. It tells the software how to process the data without crashing.
But the business executives don't care about character limits. They care about business metadata.
Exactly. Business metadata bridges the gap to human understanding. It includes robust business glossaries and data dictionaries. Let me give you a mechanical example. A business user opens a BI dashboard and sees a massive chart tracking a metric called net profit. The business metadata is the underlying documentation that explains exactly which mathematical formula was used to calculate net profit, which specific financial data streams feed into that calculation, which data steward in the accounting department officially owns that definition, and the exact date that formula was last audited for accuracy.
The text includes a fascinating diagram showing how these layers connect. It traces how an abstract business glossary term like customer credit limit conceptually links down through the logical data model attributes and maps directly into the physical data store column on a specific server in a specific rack.
It's all connected.
Metadata is the translation layer between the messy human reality of business strategy and the rigid silicon reality of database architecture. Organizations that fail to manage metadata fail at data management entirely because they are operating a library blindfolded.
It makes the invisible universe discoverable, understandable, and ultimately governable.
So we have officially toured the entire map. We've explored the hub and every single spoke of the DAMA Wheel. But as any executive knows, reading the architectural manual is vastly different from actually building and operating the city.
Oh, totally different.
How does a massive, complex enterprise actually look in the mirror and objectively measure if they're succeeding at any of this? How do they know if their governance is effective or if their metadata is sufficient?
They have to test themselves.
Right. This brings us to the final section of our deep dive, the reality check. Chapter 15 of the text focuses on a mechanism called the Data Management Maturity Assessment, or the DMMA.
The DMMA is a diagnostic instrument. It is a formal capability maturity assessment that evaluates an organization's current state of data management activities across all those knowledge areas, precisely to plan for strategic improvement.
How does it score them?
It objectively scores the enterprise against established industry best practices. It places the organization on a standardized maturity scale, typically ranging from level 1, which represents a chaotic, ad hoc environment where heroes constantly fight fires.
Just winging it.
Yeah, just winging it. And it goes up to level 5, which represents a highly optimized, automated, and continuously improving data ecosystem.
What are the actual mechanical drivers that force a company to undergo this process? Because an enterprise-wide audit of your internal infrastructure sounds like an incredibly invasive, intensive operation.
The drivers are both external and internal. Externally, regulation is a massive driver. Government regulators and auditors often demand to see empirical proof that a financial institution or a healthcare provider has mature systemic processes for handling sensitive data rather than just taking their word for it.
Why prove it?
Exactly. But internally, the DMMA is used primarily for governance planning. It provides a common, objective language that finally bridges the communication gap between the IT department and the business executives.
I see. Instead of the IT director vaguely complaining in a board meeting that the legacy databases are a mess and we need more money, the DMMA provides quantifiable, heavily documented metrics.
Exactly. The report says, we have empirically measured our data quality capabilities, and we are operating at a level 1 maturity. This specific deficiency is exposing the enterprise to $15 million in projected regulatory fines and operational waste annually. We require a $3 million targeted investment to reach level 3 maturity.
So it translates technical debt into financial risk.
Precisely.
But let me put myself in the shoes of a CEO for a moment. Agreeing to a comprehensive DMMA sounds terrifying. I am basically authorizing an internal or external auditor to poke through every dark corner of my digital infrastructure, find every skeleton in the closet, and produce a legally discoverable document detailing exactly how disastrously messy my house is.
It's a scary thought.
How do you convince a C-suite to willingly embrace that level of documented vulnerability?
It is a highly rational fear. The DMBOK explicitly acknowledges the risks associated with DMMAs. If the scope is too broad, the organization can uncover a reality so fundamentally broken and bleak that leadership simply becomes paralyzed by the scale of the necessary remediation.
Shut down.
Yeah, so the text suggests a structural mitigation strategy. Do not audit the entire global enterprise on day one. Start small. Run a pilot assessment on a single critical business unit or a specific high-priority data domain like customer data.
Prove the concept first.
Right. Prove the value of the assessment, build the remediation muscles on a smaller scale, and then expand.
And to answer my own question about why a CEO would willingly authorize it,
Yeah.
because in the modern information economy, willful ignorance is no longer a viable legal or operational defense.
No, it's not.
The systemic risks of data disparity, unethical algorithms, and unsecured infrastructure are simply too high to pretend the invisible universe is functioning fine just because the website loads.
The DMMA is ultimately a profound culture change tool. The actual act of conducting the assessment forces desperately siloed teams to sit in a room together and communicate about shared pain points.
That gets them talking.
It educates the broader business on what data management actually entails. It transforms vague frustrations with bad reports into a targeted strategic roadmap with clear investment options that the C-suite can understand, fund, and track over time. It is the critical first step in taking deliberate control of your destiny as a data-driven organization.
Let's pull all of this together because this has been a massive, intricate journey through the digital architecture that underpins the modern world.
It really has.
We began by fundamentally redefining our terms, shifting data from a passive IT byproduct into an immensely valuable, non-depletable enterprise asset. We mapped the chaos of that invisible universe using the DAMA Wheel, identifying data governance not as a bottleneck, but as the central hub and the traffic light system holding everything together, heavily emphasizing the ethical mandate of treating data points as human lives.
Absolutely crucial.
We translated strategy into reality by building the blueprint and the vault through data architecture, modeling, and robust storage operations. We navigated the vulnerabilities of moving data through security matrices, ETL integration, and data quality, realizing that semantic data disparity is a far greater threat than simple typos.
Much greater.
We sought the single version of the truth through master data entity resolution and the rigorous management of unstructured document lifecycles. We unlocked the analytical crown jewels with business intelligence, all made entirely possible by the connective magic of metadata acting as our enterprise card catalog. And finally, we grounded the entire discipline with the objective reality check of the Data Management Maturity Assessment.
It is an incredibly comprehensive, heavily interconnected framework because the modern reality of enterprise information demands nothing less. You cannot selectively ignore any of those 10 spokes without compromising the structural integrity of the entire wheel.
But as we close this out, I want to leave you, the listener, with a final thought to mull over. We have spent this entire deep dive examining how massive, multinational corporations must apply strict governance, rigorous architecture, and maturity assessments simply to survive the sheer gravity of their own data.
Right.
But consider your own personal life. In the modern era, You are essentially a walking, breathing enterprise of unstructured data. You have decades of digital photos scattered across different legacy cloud platforms.
Oh, definitely.
You have years of emails, complex behavioral footprints across social media, dozens of compromised passwords, and financial records siloed in different banking apps. If your personal life was audited using the DAMA DMBOK framework today, what level of maturity would you score?
That's a scary thought.
Do you have a personal metadata strategy to find that one important tax document from 5 years ago? Do you have a personal data governance strategy, or are you just perpetually hoping your hard drive doesn't crash?
We are all generating our own massive hidden digital universes every single day. The same principles of architecture and risk apply to us.
Something to think about the next time you blindly click Save As on a document. Take a look at your own digital footprint differently today. Thank you for joining us on this expansive deep dive into the invisible, fascinating world of data management.